Anybody have any questions before we start today? Consequence for not passing the test online is that you have to take it again and keep taking it until you actually pass it. That'll be the ultimate consequence. So, what did I say? That was going to be due tonight at midnight, right? So, get on the My Econ Lab and do your quiz. Any other questions on that homework or quiz? All right, so last time, we made a pretty impressive argument about the benefits of trade and how we can make people better off by allowing them the freedom to exchange, do what they're best at, and trade with other people for things they're not as good at. So today we're going to extend that into international trade and kind of ramp it up to the country level. Before we do, though, I want to, I guess, tie this back to a couple of our handouts here on the economy according to Russ. And think about the basic problem here, which, there we go. So I want to think about this one. So this is our island that we all live on, loosely characterized as society. What's the difference between a society and an economy? Not much. I think when we add the economy business, hopefully what we learned from Tom and Jen on the island is that we've got individuals engaged in trade in the pursuit of happiness. So they're engaged in trade in some capacity, or they have the freedom to do so to make each other better off. So that's the maybe subtle distinction between a society and an economy. So we've got that trade aspect. So we left off last time with a board picture with my markers and whatnot, which isn't quite as pretty as this picture. But what I want you to conceptualize is at any given point in time, we could take an inventory of the resources in the economy. Land, labor, capital, entrepreneurship. So we defined those last time. Labor being some human beings that are willing and able to work. We got an inventory of those people that we could count up at a point in time. The amount of land, which is more than just acres of land. We can talk about the soil, the composition of the soil, air quality, rain, sunshine, wind, any natural resources we're going to put in our land bucket. So we can think about having an inventory of natural resources at our disposal to use. Capital are man-made things that help make other things. So think of physical items like buildings, machinery, screwdrivers, in some cases pencils, computers, kind of physical things that help make other things. And then entrepreneurship, it's kind of a unique one. I think of that bucket being full of maybe some knowledge and what economists generally call human capital. So how do we put these things together? What sort of processes do we have in place? How do we pool together the resources in such a way that we make these products, right? So to some degree, we're thinking about the accumulation of knowledge maybe in that bucket, as well as the initiative and desire to want to create something. Okay, so here we are sitting around on our island. How do we have progress over time? Well, one way we can think about that is through changes in the levels to these buckets. So the basic resources are what is used to make the final goods we care about. What goods? pizza, chicken wings, dental services, education, you name it, all the stuff on the shelves at Walmart, those outputs, those final goods and services, we use these resources to make that stuff. So where do we find economic growth? Ultimately, at its core, we need growth of the resource base. We need growth of these buckets. And so we want to pay special attention to what's happening to these buckets over time, which raises the issue of distinction of items called stock variables and flow variables, stocks and flows. So a stock variable has meaning at a point in time. A flow variable needs a time dimension to have meaning. All right, so if I told you I make $135,000, am I doing okay? Is that a decent amount of money? 135 grand?
Depends on the time period.
All right, depends on the time frame. Some of you have had my class. I kind of hit this almost in all my classes. Management class, other econ classes, stock variable versus flow variable. So 135,000 is really a meaningless number if we're thinking about your income, because a lot of you implicitly thought that I was meaning 135,000 per year, but I didn't say that. I just said, suppose I make 135,000. Because if I told you I made 135,000 over the last 10 years, I'm quickly in the poorhouse, right? I'm very poor, making $13,500 a year rather than 135,000 a year. I go from fairly rich to poverty level just in the blink of an eye by saying that my income was over a 10-year period as opposed to a 1-year period. Furthermore, I could have made myself pretty rich by saying I made $135,000 a month. Now I'm way up there in income level really quickly. So the point is, the variable income has no meaning unless there's a time dimension associated with it. So the variable income of 135,000, so this would be the level of that variable, or the amount, or the quantity. That variable income with $135,000 amount, or quantity if you will, has no meaning unless it has the time dimension per year, per month, per 10-year period. It's completely meaningless without the time dimension. All right, so income is a flow variable because it only has meaning when a time dimension is specified. So per month, per year, per 10 years, all has different implications for our 135,000. So if I told you I have 135,000 in my checking account, does that have meaning? 135,000 in my checking account. Does that have any meaning?
Yeah, because it's right now.
It's right now. So in other words, let me phrase the question or characterize it a little differently. I've got $135,000 in my checking account, and I'm taking the whole class to downtown Kansas City, and we're not leaving until the checking account reads 0. Does that have meaning to you now? We're going to have a fun time tonight, right? All right, this is a little bit of dreamland here, but that all of a sudden has meaning. So the 135,000 has meaning at a point in time. It has meaning without a time dimension specified. So the variable in that case would be your checking account balance. if your checking account has 135,000, it's not per year, it's not per month, it's 135,000. And you guys know what damage we could do on a given night with 135 grand, even with all 60 of us going, right? So 135 grand in the checking account. This is a stock variable because it has meaning at a point in time. So it's helpful when we're going to talk about a lot of variables in this class, and it's kind of helpful to keep that in mind. Stock or flow? Stock or flow? Sometimes we get sloppy and we might say, oh, your income's 135,000, and we don't say per year. But implicitly we were saying it or meaning it. So be thinking about that. So back to this picture then. Economic growth comes from the changes and growth in the stock of resources. So what's inside the buckets is at a point in time. The bucket levels are stock variables. How they change over time is the flow. So in the case of capital, which is the machinery, computers, and buildings, over the course of the year, we invest. We have some investment. And so, well, I invested $135,000. Well, what does that mean? I bought $135,000 of computers this year for my company, right? So there was a flow of computers into my capital bucket. But at the same time, a certain amount of those computers wore out or became obsolete, and I threw them in the garbage can, right? So there was a hole in the bucket. And so the net effect on the bucket level at the end of the year was the flows versus the leakages. What was bigger? If we had more flowing in than what, at the back looks like there's an open spot there, Michael. If we had more flowing in than what leaked out, the bucket level went up. If we had more flow out than what came in, the bucket level falls. Okay? Stock and flows. All right. So an amazing thing goes on daily in the United States and other countries. These resources that, for the most part, we don't really give a rip about, get transformed into the things we do care about. So we got our pizza, shirts, and basketballs there. Those are our outputs, or our final goods and services. They get converted by squishing together these resources into the stuff we ultimately want. So we'll spend some time in future chapters on that production process and thinking about the economics behind that. All right, I think, well, I gotta go to the next one too, at least the next one. This next picture is an important one. With Tom and Jen on the island, who was the better fisherman or fisher person? Jen, right? So we determined that Jen had a comparative advantage in fishing. She was able to fish at a relatively lower cost than what Tom could. On the flip side, Tom had a comparative advantage in coconut harvesting. And so the way they made each other better off was Tom specialized in coconuts, Jen did the fishing. They met together, traded, and made each other better off. How does that scale up into an island with 300 million people on it, right? Well, the way that scales up is through, in a market-based economy, is through the creation of firms and households doing trades with each other. Now, in the household section, this is what society's all about. All people reside in a household at some point during the day. Not everybody resides over here, right? In fact, in the United States, it's about half. we'll get into that discussion in chapters 4 and 5 when we talk about the labor force and labor force participation rate and stuff like that. So we've got old people and kids and people who choose not to work for whatever reason. Everybody's over here. A fraction of the population works collectively within a firm to do what they're best at, presumably. Sometimes they go to school and get special skills, whether that's a trade or whether that's a bachelor's degree at Ottawa University. They figure out what they're best at, and then they go to the market with those skills, and somebody's attracted and needs them for their particular thing that they do, and they specialize. So just like Tom and Jen on the island, we have the formation of companies and businesses that give us the specialization aspect of what we had on the island with comparative advantage. All right, questions or comments on that? All right, so the last one I'm going to just flash, but not really go through the details. This was Tom and Jen doing the trades, and then we'll think about how goods and services flow from one place to the other in exchange for resources. All right, so we'll come back to that when we get into chapter 4. Before we do that, we're going to dive right into chapter 15. And so part of what I'm going to present today is on a bit of a review in a different way, the model that we went through with Tom and Jen, except now we're going to have Japan and the United States engaging in some trade. And then we're going to talk about other international trade issues. Okay, so here's what I love about international trade. So this is chapter 15. The basis for international trade is simply recognizing the fact that countries are different. And then exploiting those differences. To benefit all countries involved. I mean, this is what really attracted me to international trade as a area of specialty. Economists sometimes throw out outlandish assumptions at things. Remember, our economic model is a simplification of the chaos that's really going on out there in the world of trade. And so you got to kind of watch out for the assumptions. Well, at its core, the assumption that's made for international trade to be beneficial to countries involved is that you can't have the countries be identical. Otherwise, it doesn't work. But as long as countries are different, then we should be able to have some gains for trade for both countries, similar to our Tom and Jen experience. Okay, so how are countries different? Types of differences. Resources, good. Like what? Give me some maybe specific examples. So we got lots of different resources, land, labor, capital, entrepreneurship. Give me some, just a couple examples of things that came to mind. Oil, okay, so oil reserves, good. So oil reserves. Some places have them, some places don't. What else? Crops, agriculture, weather, climate, all that type of stuff. We see we can't do oranges in Canada very well, right? So what else? How about on the labor side of things? what can be different among countries that have differences in the labor force? Population, just sheer numbers would be one. Good. What else? Education, the amount of education that each one has. Labor laws. So now we can enter the government and restrictions into that. Good. So population, education. There could be different laws and regulations. So then we're kind of getting in different, might be a separate subheading here of governments. We have different regimes. Some could be more centrally planned systems, Fidel Castro in Cuba versus more free market systems of the United States and Japan, more socialist systems. Over in Europe, France comes to mind. Okay, good. So lots of different differences that can lead to some possibilities to benefit countries. All right, so some reasons for trade. One easy reason that's kind of like skimming the cream off the top is just to acquire goods that you can't do yourself. So if you can acquire goods, I'm just going to use loosely the word you, but a country, acquire goods you can't make yourself. Is it possible for the United States to grow enough coffee to satisfy coffee demand for U.S. consumers? Is it possible, do you think the United States, I haven't looked at that data, but I really doubt it. I don't think our climate and our current conditions would allow us to make enough coffee to supply all that's demanded currently anyway at today's prices. So, you know, we might want to buy some coffee. Again, if we're in Canada, we might want to buy some oranges. So that's kind of a simple argument for trade. The tougher one is trading when you can make it yourself. Then we get into the arguments of, well, we should buy U.S. goods. Why don't we just make that ourselves? Why are we shipping all the manufacturing jobs over to China and Vietnam? Why don't we just do it ourselves? You know, kind of this protectionist thought. So that's where it becomes a lot more difficult, and that's where really the arguments within the trade world are. So, so reasons for trade, number 2, would be to make a country better off through specialization. And trade. All right, so the key part to this is opportunity cost, just like we saw with Tom and Jen. Who was better at fish and coconut harvesting? Tom was. So Tom was better at producing both. Tom had an absolute advantage in the production of both goods, but yet we proved that even Tom could be made better off by following this thought here. Specialize in what you're good at, trade for what you're not good at. So one of the key things that we don't want to forget about is there is an opportunity cost. There is an opportunity cost to production of anything. The famous econ line that you may have heard of, but you never knew that it came from econ, was that there's no such thing as a free lunch. I can't remember who to give that credit to, but there's no such thing as a free lunch. And that's what opportunity costs are all about, is recognizing that if you're doing something, you can't be doing something else. There's always a cost to doing something. whenever you're doing something, you're giving up something else, whether it's through time or through dollars. You're giving up other opportunities. All right, so opportunity cost, for a definition here, is the cost of something, measured in terms of what was given up. The cost of something measured in terms of what was given up to get an additional unit. The cost of something measured in terms of what was given up to get an additional unit. I'm cheating slightly on that definition by sneaking in this word additional unit. That really changes it to a marginal cost. A marginal cost, the cost of an additional unit. So what did we give up to get an additional unit? I like to blend these together right away so that you guys start thinking in terms of the incremental unit, which is so key in economics class. So the word additional really makes this a marginal cost, marginal opportunity cost. So given that, I want to offer you a little more generic definition also. So another way to think about opportunity cost is that it's the highest valued alternative foregone. The highest valued alternative foregone. So that kind of strips the unit business out of there, the additional unit, although it can be very similar. All right, so Jesse, if you weren't in class today, what would you be doing? Sleeping. Dom, if you weren't in class today, what would you be doing? Another sleeping. Travis, what would you be doing? Sleeping at 11. Mallory. At lunch. Blake. Eating. All right, so let me just stop there. We got some sleepers. We got some eaters. So we got sleeping, eating, and what was my other thing?
That was all you got. Yep.
Was it sleeping and eating was it? All right, give me some. What else?
Work.
Just one more. Work. Hey, we got a worker here. We might be able to have a job. All right. So, is it possible that all of you face this set of alternatives? Could all of you be eating? How many people eat usually on a given day? Raise your hand. All right. Good. So we got some eaters. So that's an alternative. You might not be what you were doing, as we went around the room, but all of these are alternatives. The point I want to make is that the opportunity cost is not all of these things. It's the thing you would have done if you didn't do what you did. That's my Dr. Seuss portion of this. So it's the thing you would have done if you didn't do what you did. The thing you would have done. So opportunity cost is the thing you would have done if you didn't do what you did. Opportunity cost is the thing you would have done if you didn't do what you did. So it's only one of these things. It is the highest valued one, the thing you would have done. So there's only one right answer. That answer might be different for all of you. Some of you might be eating some lunch, some of you might be working, some of you might be lifting weights, whatever the case is, but it's only one thing. It's the thing you would have done. It's not all of them. It's the highest valued alternative. Okay, questions or comments on that? All right, well, let's get to our Ricardian trade model here. This model we're going to look at was developed by an economist who was a fan of Adam Smith, came shortly after Adam Smith, named David Ricardo. He was one of the first economists to really start to put numbers to things and to think a little more quantitatively about these arguments. And he was trying to persuade the King of England to engage in trade with France. And so the model that we're going to go through is the exact same model, not I'm using different countries and different goods, but the format is the same as what he presented the king to try to prove that Great Britain should engage in some trade. All right, so we call this the we can call this the Ricardian trade model, or the comparative advantage trade model. I like to give kudos to David Ricardo since he kind of invented this thing. So we're going to look at a 2-by-2 situation. So here's our assumptions. Suppose we've got two countries, the US and Japan. And we've got two goods, food and cars. And we've got one resource or factor of production. One resource or factor of production. And that's going to be labor. We're going to show the country's labor productivities in a little box, kind of like having some schedule goggles on here. But so draw a little 4-square box, and let's put the United States here and Japan here, and we'll put food with an F and cars with a C. And in the United States, one worker on average can make 4 units of food. So we're just going to put a 4 there. And then the notation I want to think about is 4 units of food per labor, F over L. 4 units of food per unit of labor. That same American worker on average could be making 8 cars. So we got 8 cars per unit of labor. Over in Japan, we're going to do the same thing. A Japanese worker on average can produce 5 units of food per labor. Or that Japanese worker could be producing 25 cars. All right. So, give me an interpretation of these numbers. What are these numbers speaking to you? Japan has an absolute advantage. Okay, good. So you're putting the technical language. What does an absolute advantage mean, Rachel? Better at both things, right? So on average, the Japanese are more productive. They have a more productive labor force. Why? Because on average, one worker could be doing 5, or they could be doing 25. Up here, the potentially fat, lazy Americans can only do 4 or 8. All right, so this is how David Ricardo tilted the scale. Who do you think, when he was presenting to the King of England to try to engage in trade, which one was Great Britain, Japan or the United States? Japan, right? He's trying to butter him up. He's trying to say, okay, listen, King, I know that you are better at everything, of course. We yield to the Brits, but I want to persuade you a little bit further, right? So this really stacks the deck for Japan and against the United States. Like, why would the Japanese ever want to trade with the United States? All right, so a couple other little cleanup things here. As a part of our notation that we're going to use, since we're in the United States right now, I'm going to call Japan the foreign country. And so we're going to put a little asterisk by their numbers, and you'll see this kind of come through later. So the little star, the asterisk, denotes the foreign country. It's just kind of handy when we get into things later. All right, so this is our first introduction into what we call labor productivity, which we'll study later as well. So note the numbers in the table represent labor productivity. So it is the number of units of output, more generically speaking here, the number of units of output per unit of labor on average, per unit of labor. It's telling us how productive our labor force is. Okay, last assumption before we start building up this model. You brought up population. Somebody said the population of labor, so I'm going to add that into the mix here. So assume that the U.S. Labor force is equal to 1,000 people, 1,000 L, and Japan's labor force is, oops, I screwed that up. Japan's is 1,000. We're going to make United States the bigger country. The United States has 2,000 workers. So we've got 2,000 workers in the United States, 1,000 in Japan. And let's take a look at their production possibilities. I want a little bit more room. Did everybody get that? Yell if you need that. I'll probably rewrite it here in a sec. So I want you to graph two things side by side with each other. They're not really connected, but kind of helpful to draw them this way. So the graph to the left is going to be the United States. The graph to the right is Japan. We're going to measure food on the horizontal axis for both countries. So let's just put a F star for Japan. And we'll put cars on the vertical axis. for both countries again. Let's draw the production possibilities for each country. How do we start doing that? We did production possibilities for Tom and Jen. That helps you start thinking, get the brain declogged. Yep, we got, all we have is the data in front of you. We got these numbers for labor productivities. We know that the labor force in the United States is 2,000 and the labor force in Japan is 1,000. That's all we got to work with. How do we go about drawing the production possibilities for each country?
When you say like 4 and 8, is that like 4, like what's the unit?
So this is 4 units of food per unit of labor.
So like if 1,000 is all of one, or if all of 2,000 were working on food, then they produce 4 units.
4 units each on average, giving a
so
grand total of 8,000.
Oh yeah.
Yes, so you're absolutely right. So this is the average labor productivity. On average, each one of these workers can make 4 food. I've got 2,000 of them. So the country's production possibilities are 8,000 food. Where's that? The bottom, where? A little more specific? U.S., a little more specific? Horizontal axis, good, right? So it's the intercept. So somewhere along here, if we maybe draw a little bit careful here, we got, let's say 2, 4, 6, 8. So we got 8,000. So let's say that food is being measured in thousands, and cars will be measured in thousands, just to kind of help out the, I don't have to write the 3 zeros after it. Did I see a question, Chelsea?
I just want to make sure like it's either 4 or 8, not 4 and 8.
That's right. It's 4 or 8. So this is the labor productivity for cars, labor productivity for food. So that brings me to my next question, Chelsea, if you want to jump on this. If that is the interpretation that it's 4 or 8, what's another point on the production possibilities curve? One point is right there, 16. All right? So we can throw all of our labor if we fully specialize in car production. The most cars we could make would be 8 times 2,000 gives me 16. So 2, 4, 6, 8, 10, 12, 14, 16. There's another point on the production possibilities curve or frontier. Where else could we be? Cut it in half. So if I put 1,000 workers into food and 1,000 workers into cars, I'm going to be at 4,000 and 8,000, right? So 2, 4, and 2, 4, 6, 8. Now if I drew this real carefully, tell me about where this point belongs. If you guys draw your graphs real carefully, got out some graph paper, what can you tell me about these 3 points? What's special about them? It'll be in the middle, yes. Just a little more specific. What else about it? It's a line. That's an important part of this. It's a bit of a simplification, by the way. We'll come back to that later. But it would be a line, similar to what we had with Tom and Jen. So if you draw this real carefully, it'll be a line, which further means if I put 200 workers into food and 1,800 workers into cars, I'm going to be somewhere along this line. These represent all of the production possibilities for the United States. They could be here, they could be here, they could be here, they could be here, they could be anywhere along that curve. So this is the production possibilities curve. It's also called the frontier. Sometimes I use that. The production possibilities curve for the United States. What's going on in Japan? $5,000 what? Food. So along the food axis, if they devoted all of their scarce resources, which happens to be just one for this model, if they devote all 1,000 workers to food production, they could have 1, 2, 3, 4, 5. So that represents 1 point on their production possibilities curve. Where's the other point? 25,000. So I'm just trying to draw approximately evenly spaced. They don't have to match these hash marks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And if we split up the labor force, they could be anywhere along that production possibilities curve. So now we've got the production possibilities mapped out for each country. So where we're going with this is we need to figure out what each country's best at. So what is the opportunity cost of food in the United States? What is the opportunity cost? So the opportunity cost of a food, one food, in the U.S. is how much? 2 cars. 2 cars. How'd you get that? Ratio? Slope? All of these are ways. So why I'm saying this is there's multiple ways to get this answer. So slope, maybe you think of ratio. I'd like a little more comments on the ratio. John, how did you do it?
I just divided 8 by 4.
You just know, right? You just saw. Divided what by 4?
I tried to get the food down to 1 unit, so I divided it by 4 and then divided the 8 by 4.
Okay, so I'm going to go in slow motion because I know maybe your brain goes at light speed or something and you just jump right to it. So and this kind of plays into Chelsea's comments here. In the United States, 1 worker can make 4 cars or equivalently 8 food. Oops, did I do? Yes, I need to switch that around. 4 food or 8 cars. I want the cost of 1 food. So now that I got my equation goggles on, I can make a 1 over here by doing what? Divide by 4, 1 food. Well, what I do to one side of the equal sign, I got to do to the other side. 1 food can be traded for 2 cars. That's the trade-off, which, as Rhiannon pointed out, plays into the slope of this line. What does a food cost me? I can give up 2, get 1. Give up 2, get 1. Fall 2, run 1. Rise over run. It's the slope of this line is showing the trade-offs of food and cars for the United States. So the opportunity cost of food in the United States is 2 cars. All right, we will pick up there on Friday.